Hello everyone, this is Arya from Edureka. Today's video is all about blockchain interview questions. So first of all, we're going to discuss the blockchains in the market. Next, we're going to discuss the general blockchain questions that are asked in the interviews. And we're also going to go through the advanced blockchain questions. So let's begin. Now if you see this graph, you'll see that since 2013 and 14, the job positions on LinkedIn have increased with an upward curve. All these job postings have been across multiple job segments. So if you observe the graph, the most number of job opportunities are coming up in the technology, that is the software field, and the financial services and insurance services. Then there are opportunities in non-technical domains as well, like media industries, telecommunication, professional services, and many more. So on an average, post 2015, you'll find blockchain has been quite a happening place to be in because everyone is exploring proof of concepts, trying to build solutions around blockchain, and that is what is driving the entire job postings in the market. Now just to look at the forecast, going by the past trends, you see that what you see today is nothing compared to what we're going to see in the next 7 years. So in the next 7 years, the number of jobs in blockchain are going to grow by 16 times, which is quite a big number. So this is an opportunity. I personally feel that this is the right time to be in this field. And if you see on the right side of the slide, you'll find that if you know blockchain, there are 14 jobs for you. So that is quite a mismatch in the demand and supply. Alright, so let's come to the next part. I have divided the interview questions into two parts, namely advanced and general. We'll start with some of the basics but important questions asked in blockchain interviews. Then we'll move on to the more advanced interview questions. So let's get started with the general interview questions. So the most basic question is, what do you know about blockchain? And the answer to that is, blockchain is a decentralized distributed database of immutable records, where transactions are protected by strong cryptographic algorithms and the network status is maintained by a consensus algorithm. Now the blockchain is devised in such a way that to access any previous transaction, you have to traverse from the last created block to the block whose data you want to access. Now the second question is, what is the principle on which blockchain technology is based on? The answer to that is, basically, we can say that blockchain is a subset of distributed ledger technology. So we can say that all blockchains are DLTs, but all DLTs are not exactly blockchains. Moving on to the next question, what are the different types of blockchains that are available? So basically, at a high level, there are three different types of blockchains. One is public blockchain, which is open blockchains. So blockchain platforms like Bitcoin, Ethereum, Monero all come under public blockchains, which anyone can join. So if you want to become a part of any public network, you just have to download the software and you can start running the node on your own. You don't need to take anyone's permission, which basically makes these networks permissionless. Then the next type of blockchain is private blockchain. All permissions are kept centralized to an organization. Private blockchains allow only specific people in the organization to verify and add transactions to blocks, but everyone on the internet is generally allowed to view them. Some of the examples are multi-chain, block stacks, and so on. Now the third type of blockchain is called consortium. This is also a type of private blockchain, but this is managed by a group of individuals or by a consortium of members. Only predefined set of nodes have access to write the data or a block. Hyperledger is the most popular example of a consortium blockchain. Moving on to the next question, which is, why is blockchain called a trusted approach? Now the reason why blockchain is trusted is because of its immutability, which means that once a transaction is being written onto the ledger, you cannot modify it. Also, every participant has a shared source of truth. Basically, it distributes trust among different individuals of the network via an economic game wherein the individuals are incentivized to maintain the state and validate the transactions. Now the next question is, what type of records can be kept on the blockchain? Is there any restrictions on the same? So the answer to that is, there are no restrictions as such on any kind of data that you can actually store on the blockchain. There are different companies using different types of blockchains for holding all sorts of records. Some of common types that you see here are records of medical transactions, identity management, transaction processing, business transactions, managed activities, documentations, and so on. So there is practically no limit on the kind of data that you're pushing onto the blockchain. Alright, the next question is, blockchain is a decentralized database. How does it differ from traditional databases? So if you look at the table, it says that the record in blockchains are stored in a decentralized database. Whereas in traditional databases, the records are centralized. Talking about the operations, blockchain only has insert-only operations, while in databases, you can perform CRUD operations, which stands for create, read, update, and delete. Since the ledger in blockchain is distributed to the entire nodes of network, the traditional databases have more of a multi-master and master-slave architecture. Then there is consensus amongst the peers for coming to an agreement on the outcome of transactions, whereas in traditional databases, there is two-phase commit. Also, since blockchain is an open network, anybody can validate the transaction across the network. Whereas in traditional databases, there are integrity constraints, and not everybody is allowed to validate the transactions. Okay, the next question is, what are the key features of blockchain? So the most important feature of blockchain, you can say that it is a decentralized network also, and it runs by using a distributed ledger, where immutability is a very important feature, wherein data cannot be modified or deleted, which is why we can say that it is a safe and secure ecosystem. And the last feature is that it has the concept of mining, which is very specific to a blockchain. Okay, so the next question that we have is, what is encryption and what is its role in blockchain? So encryption is basically a way to secure the data. Encryption is used when you don't want someone else to be exposed to your data. The data is passed through some sort of cryptographic algorithm to scramble the data in such a form that it is non-readable to human beings. So that data is basically protected by the keys, and only the person with the cryptographic keys can decrypt or decode the encrypted data. Now this approach is really useful in blockchain because it makes the system secure and adds to the overall authenticity of the blocks and the blockchain. Any data in blockchain is encrypted using state-of-the-art cryptographic algorithms, and the blocks are linked together using the encryption techniques. That is what makes it so useful and secure. Okay, let's move on to the next question. So the next question says, what do you mean by blocks in a blockchain technology? Well, we said that blockchain is a distributed ledger that contains a list of transactions. Now these transactions or records are stored in the form of blocks. The blocks are necessary to maintain the order of transactions in blockchain, and each of this block is linked to each other in a sequential form. So whenever a new transaction comes in, it is added to the block. This block is linked to the latest previous block, and so on and so forth. Now the next question is, how is a block recognized in the blockchain approach? So every block in the blockchain consists of a pointer which acts as a link to the block prior to it. So every blockchain has a header which has the transaction data, timestamp, and also the hash of the previous block. So every block is linked to the previous block using the hash pointer. Okay, so moving on to the next question. This should be very basic. Is it possible to modify the data once it is written in a block? So as we all know, blockchain is immutable, so the answer is obviously no. We saw earlier that transactions or records in a blockchain can only be written in once, and it cannot be changed. Since all the records are secured by cryptographic algorithms, any changes in any of these records will result in the change in the hash of all the blocks prior to it, so the chain breaks. So because of this, it cannot be modified because it will change the hash of the entire directory. Now the next question is, what are block identifiers? In a blockchain, there are ways to identify blocks, and these are called block identifiers. Basically, there are two ways to do that. Every block has a block header which points to the previous block, and then we have a block height. The block height is nothing but the number of blocks in the blockchain. So basically, you can identify the block with the block header hash or the block height. Moving on to the next question. Is it possible in blockchain to remove one or more blocks? Well, this is a very easy question, and the answer is no. This is not possible, as removing or detaching any block will disrupt the hash header of all the previous blocks, so you just cannot do this. Moving on, what exactly do you know about the security of a block? So the primary method of protecting a blockchain is by using cryptographic hash algorithms, and each block is linked to another using a hash pointer. So any modification in any records will change the hash identifier of the whole block. Also, one more thing which makes the blockchain secure is the consensus algorithm. The consensus mechanism maintains the state of a blockchain and also acts as a network servicing protocol. Moving on to the next question. What are Merkel trees and how important are Merkel trees in blockchain? So Merkel tree is also known as the hash tree. It is the data structure in blockchain in which each leaf node is a hash of a block of data, and each non-leaf node is a hash of its own child nodes. Merkel tree helps you identify a specific data very quickly. Let's say we have 1,000,000 blocks and we quickly want to identify a transaction or block. So the Merkel helps us do it without traversing the entire history of transaction. Alright, let's have a look at the diagram shown here. So if you see, the Merkel tree summarizes the transactions in a block by producing a digital fingerprint of the entire set of transactions. So what do we mean by this is that Merkel trees are created by repeatedly hashing the records together until there is only one hash left. In the diagram, you can see that there is a transaction root at every block, and this transaction root is derived from Merkel tree, and this Merkel tree actually derived from hashes of pair of transactions. Moving on to the next question. What is a ledger, and is blockchain an incorruptible ledger? Let's have a look at the first part of the question. So the ledger is simply a record of transactions and these transactions are nothing but transfer of value. Person A transfers some money to person B, and that becomes a transaction, and such type of transactions are recorded in a ledger. Now, blockchain is considered incorruptible, and so what do we mean by this? What we mean is that you cannot hack or corrupt the ledger, simply because it is distributed, and if you want to corrupt a ledger, you have to control more than half of the network's computational power or nodes. And doing this is not an easy job, because if an attacker wants to control this and try to control the money for himself, he has to invest huge computational resources. So should it happen? Basically, if someone has control of more than 51% computing power in a network, that person would take every precaution to avoid being noticed. But the resources required to take control of such a system is huge. But it is near impossible for one person or community to have such huge computational power. Alright, so let's move ahead. So the next question is, name the common type of network systems that are extensively being used in various applications. So there are three types of network systems. One, you have a centralized network. Secondly, a decentralized, and third, a distributed type. So what happens in a centralized network is that every participant or node in the network can talk to each other only through a centralized node or server. You can see that from the leftmost diagram. If you look at the second one, it represents a decentralized network. So instead of nodes talking to one single server, you can actually group nodes such that few of them have single centralized server, and each of these centralized servers talk to each other. Now in a network like Bitcoin and Ethereum, where we say that it is a distributed network, what happens is that every node talks in a peer-to-peer manner. There is no centralized server of any kind in the system at all. Moving on to the next question, how is a blockchain ledger different from the ordinary one? So in a blockchain, same copy of ledgers exists in the entire network, while in the ordinary system, the ledger may or may not be the same. In blockchain, you only have options to create and read, whereas in ordinary ledgers, you can perform all CRUD options. Now, these are some of the basic differences between blockchain and ordinary ledgers. Moving on to the next question, and this is a very interesting one, which says, what do you mean by mining? So, mining is the process of transaction verification and adding those transactions to the block. Now, how does this happen? So there are special nodes called miners which use state-of-the-art cryptographic algorithms to validate the transaction across the network and add these transactions to the block. Okay, so moving on to the next question again. A distributed digital ledger is used for recording transactions on a blockchain. What does the system rely on? So the answer to that is, when we say that what we are recording transactions in a distributed ledger, the underlying network is basically composed of different nodes. So the system relies on the nodes or the full nodes and the mining nodes, which are responsible for maintaining the security and smooth running of the system. Next question, can you explain the components of a blockchain system? Okay, so the answer is pretty simple. The basic components in a blockchain ecosystem are the shared ledger, which is the digital ledger distributed among the peers. And then there is a node application which you install and run on a computer to become a part of a particular blockchain network. Then there is a virtual machine, where the instructions are implemented and every participant in the ecosystem runs that virtual machine. Lastly, of course, there is a consensus mechanism which is implemented as a part of the node application. It provides the rule for how the ecosystem will arrive at a single view of the ledger. Moving on to the next question, we have state the difference between how proof of work and proof of stake. So we have properties of proof of work and proof of stake. In proof of work, the probability of mining a block depends on the amount of work a miner does for validating the mining of a block, whereas proof of work has stakeholders and they validate new blocks by utilizing their share of coins on the network. Next point is that proof of work takes more energy than proof of stake, which is why Ethereum is gradually shifting to the proof of stake consensus mechanism. Proof of work takes up computer speed for mining blocks, while in proof of stake, user needs to own a majority of coins in order to attack the network. Moving on to the next question, name some of the popular platforms for developing blockchain applications. So people are experimenting a lot with blockchain technology, which is why there are so many platforms coming up for the building of blockchain applications. Some of the popular platforms are Ethereum, Hyperledger Fabric, Corda, Cardano, IOTA, and Quorum. So some of these networks are public networks that also work in a private setting, like Ethereum is a public network, but you can also deploy it in a local setting, whereas Hyperledger Fabric is completely private and permission network where it has no concept of a coin and it is purely used in a consortium and private manner. Now moving on to the next question is, what is double spending and is it possible to double spend in a blockchain system? So double spending is a condition where one digital token is spent multiple times because the token is a digital file which can be easily copied. Now what happens is a person named A try to send some coins to person B and person C at the same time. The blockchain prevents such a case, since the transactions are confirmed by multiple parties and it is not possible to double spend a crypto token in a blockchain. Moving on to the next question, what are the benefits of blockchain that you know of? So there are some major benefits of using blockchain, which is why blockchain has become popular in recent times. Transaction settlement in blockchain happens in real time, so any transaction is peer-to-peer and the network itself verifies the transaction, which makes the transaction much faster. And since there are non-third parties involved, the transaction cost is also minimal. Again, the transaction and the system is secured by strong cryptographic algorithms, which in turn accounts for the immutability. Then there is an important property called user pseudonymity, which means that flow of transactions are tracked by user addresses. Okay guys, that was the end of the general interview questions. Now we'll move on to the more advanced section, which you might be asked to you in your interviews regarding your blockchain career. So let's dive into them. So the first question is, can you tell me about some of the widely used cryptographic algorithms used in blockchain? So some of the widely used algorithms in blockchain include algorithms like DES, where DES stands for Digital Encryption System. Then we also have the RSA algorithm, which is used in numerous areas concerned with digital certificates. Other algorithms include Twofish, Blowfish, and AES. Out of all these algorithms, AES is the strongest encryption algorithm to break. Moving on to the next question, we have, what do you know about forking in blockchain, and name the types of forking? Okay, so at the most basic level, a fork is what happens when a blockchain diverges into two potential paths forwards, either with regards to a network transaction history or new rule in deciding what makes a transaction valid. But forks can also be willingly introduced into the network. This occurs when developers seek to change the rules the software uses to decide whether a transaction is valid or not. Forking in each and every blockchain is different and based on the design architecture and use case for which the chain is meant for. So essentially, there are two types of forking. The first kind is a soft fork, and this means that in any change is backwards compatible. Then we have a hard fork, and in this the software upgrade that introduces a new rule to the network is incompatible with the older software. Okay, so the next question is, explain the significance of blind signatures and how it is useful. So let's tackle the first part of the question first. So a blind signature in cryptography is when digital signature is generated for a certain content, with the content itself being disguised or blinded. This generated blind sign can be verified against the original unblinded messages using conventional decryption techniques. The message is blinded by the author and signed by a different party. This system is generally deployed in privacy-related protocols, for example, electoral processes, polling campaigns, digital caching systems, etc. So moving on to the next question, which is, what is secret sharing and does it have any benefit in blockchain technology? So secret sharing, also called secret splitting, refers to methods for distributing a secret amongst a group of participants, each of whom is allocated a share of the secret. The secret can be reconstructed only when a sufficient number of possibly different types of shares are combined together. Individual shares are of no use on their own. Secret sharing essentially allows data to be stored in a decentralized way across n parties, such that any k parties can work together to reconstruct the data. But k1 parties cannot recover any information at all. N and k can be set to any values desired. All it takes is a few simple parameters tweaks in the algorithm. Now, it has its benefits in blockchain technology, as it allows private content to be divided into small parts and be sent to the destination on a decentralized network. So moving on to the next question, which is, can you explain what are off-chain transactions? So off-chain transactions refer to those transactions occurring on a cryptocurrency network which move the values outside the blockchain. Due to their zero or low cost, off-chain transactions are gaining a lot of popularity, especially among large participants. Off-chain transactions can be better understood when compared to on-chain transactions. An on-chain transaction, which is simply called a transaction, occurs and is considered valid when the blockchain is modified to reflect the transaction on the public ledger. It involves the transaction being validated and authenticated by a suitable number of participants, recording of the details of the transaction on the suitable block, and broadcasting the necessary information to the whole blockchain network, which makes it irreversible. This kind of transaction can be reversed only after a majority of the network's hashing power comes to an agreement. Essentially, every step linked to an on-chain transaction occurs on the blockchain and the blockchain status is modified to reflect the occurrence and validity in the transaction. In contrast, an off-chain transaction takes the value outside the blockchain. It can be executed using multiple methods. Okay, so moving on to the next question, which states, what do you mean by anonymity and pseudonymity in cryptocurrencies? Well, an anonymity network enables users to access the network while blocking any tracking or tracing of their identity on the internet. This type of online anonymity moves internet traffic through a worldwide network of volunteer servers. Anonymity networks prevent traffic analysis and network surveillance, or at least make it very, very difficult. A good example of this is Zcash. Now, let's discuss pseudonymity. So sometimes it is desired that a person can establish a long-term relationship with some other entity without necessarily disclosing personal identifying information to that entity. In this case, it may be useful for the person to establish a unique identifier called a pseudonym with other entities. Examples of pseudonyms are pen names, nicknames, credit card numbers or student numbers, bank account numbers, etc. Well, for a blockchain, it is mostly the block address or the account address. A pseudonym enables the other entity to link different messages from the same person and thereby to establish a long-term relationship. Now let's move on to the next question, which says, how does peer discovery work in a P2P network? So the answer to that is, on a decentralized network, when a node boots up, it has no idea about the network. Since there is no centralized resource, the most practical way would be to connect to the first discoverable node. This has certain drawbacks though, as the trust and integrity of that node is completely unknown. To address this problem, developers have hard-coded a list of trusted node parties into the network. When a node boots up, it initially connects to these trusted nodes and then begin their node discovery process by just connecting to the other node connected to these trusted nodes. This trusted list is a very small fraction of the entire number of systems on the network and therefore do not hurt the decentralized aspect of the entire system. Moving on to the next question, which is, what is a 51% attack? In my opinion, this is one of the most important questions when looking at a blockchain interview. So let's see the answer. So as its name implies, a blockchain is a chain of blocks, bundles of data that record all completed transactions during a given period of time. Once a block is finalized, mined, in the jargon it cannot be altered since a fraudulent version of the public ledger would quickly be spotted, rejected by the network's users. However, by controlling a majority of the computing power of the network, which is basically 51%, an attacker or group of attackers can interfere with the process of recording new blocks. They can prevent other miners from completing blocks, theoretically allowing them to monopolize the mining of new blocks and earn all of the rewards. They can block other users' transactions also. They can send transactions, then reverse it, making it appear as though they still had the coin that they just spent. This vulnerability, known as double spending, is the digital equivalent of a perfect counterfeit and the basic cryptographic hurdle the blockchain was built to overcome. So a network that allowed for double spending would quickly suffer a loss of confidence. Now moving on to the next question, which says, name organizations that can use blockchain technology. So any service that follows the current centralized architecture could implement blockchain in their business. Services that have any sort of online or financial transactions could make their process seamless with the help of blockchain. Nowadays, with private blockchain services like Hyperledger, even confidential processes regarding government and defense could be implemented through blockchain. The possibilities are really endless, and we are just on the road of discovery. Moving on to the next question, we have, what are the core requirements for a business blockchain? So let's first look at what exactly is a business blockchain. So business blockchain, as the name suggests, is a blockchain service that can be implemented for businesses mostly private in nature. In these cases, mostly a private or consortium blockchain is used. The requirements of a business blockchain are as follows. Firstly, we need a shared ledger, which is a common aspect of every blockchain. Secondly, there needs to be privacy and permissions. Most businesses have certain rules regarding content sharing amongst this organization. In this case, a high amount of privacy and permissions at different levels of the network are required. This is essentially provided by a consortium blockchain. Thirdly, we need smart contracts. The business always needs to implement business logic on the blockchain, and the only way to do this currently is with the implementation of smart contracts on the system. Last but not the least, we need a consensus algorithm. Just like every blockchain, a consensus protocol is obviously required for the validation of blocks into the new chain. Now moving on to the next question, what are the key principles in blockchain that are helpful in eliminating the security threats that needs to be followed? Okay, so there are a few principles to be followed for eliminating proper security threats, but this is not specific to blockchain as they can be applied to any general network. So firstly, we need to have a proper auditing process. Secondly, applications must be secured with proper role-based access control system, and there should be proper testing of every unit and the integration also. Next, the database, that is distributed ledger in this case, must be secured and encrypted using up-to-date encryption functions. Also, there should be sufficient continuity planning, and there must be ample training of the workforce to follow these best practices. Okay, so moving on to the next question, which is the blockchain different from banking ledgers? Okay, so banking uses ledgers for timestamps and transaction records just like a blockchain, but the main difference lies is in the fact that bank ledgers are not public. They're controlled by centralized authorities, that is the bank, unlike a blockchain which is completely public and open source. Moving on to the next question, can you list some of the popular consensus algorithms and why do we need different consensus mechanisms? Okay, so some of the most popular consensus mechanisms are PBFT, which stands for Practical Byzantine Fault Tolerance, Proof of Work, Proof of Stake, then there's also Proof of Burn, Delegated Proof of Stake, and Proof of Elapsed Time. Now we need different consensus mechanisms, mostly to cater to different business models. Also, new consensus mostly provide an optimization in terms of storage and performance. Other things can also be implemented like regularization requirements, implementation, performance, tokenization, security, privacy, etc. So, moving on to the next question is there any network-specific conditions for using blockchain technology in an organization? So, the only basic requirements for a network to implement blockchain is that it must be a P2P network. It helps validate the new blocks simply and helps organizations to keep up the pace in this matter without investing in third-party applications. Moving on to the next question, name the steps that are involved in the blockchain project implementations. Well, there are a total of 6 steps involved in this process. Firstly, we need to decide if we can use an existing blockchain for our purposes. For this, we need to do some requirement identification. After the requirement identification has been done, we need to screen all the ideas that have been come up while the brainstorming was being done. Next, we actually take the idea that has been chosen and implement it through some successful project development cycle. Next, we have to do some feasible study on the security and implementation. Last but not the least, we have to also take care of controlling and monitoring the project. So these are the 6 simple steps that you need to follow when deploying your blockchain project. Moving on, explain a real-life use case where blockchain is being used. So this is very easy. I have an example in front of you, which is Storj. So Storj is an open source decentralized file storage solution. It uses encryption, file sharding, and a blockchain-based hash table to store files on a peer-to-peer network. The goal is to make cloud file storage faster, cheaper, and private. Traditionally, cloud storage solutions like Dropbox or Google Drive have limitations. While files are backed up redundantly, bandwidth from a data center or unexpected outages can restrict access to your files. There are also issues of privacy, and these companies have complete control over your files, including the ability to access them. The Storj project uses blockchain and peer-to-peer network to solve these problems. It distributes the files, so redundancy is well established. It also guarantees you're only one who can access your files. Now moving on to the next questions, which is, what are sidechains? So a sidechain is a separate blockchain that is attached to its parent blockchain using a two-way peg. The two-way peg enables interchangeability of assets at a predetermined rate between the parent blockchain and the sidechain. The original blockchain is usually referred to as the main chain, and all additional blockchains are referred to the sidechain. The blockchain platform Ardor refers to its sidechains as child chains. A user on the parent chain first has to send their coins to an output address, but the coins become locked so the user is unable to spend them elsewhere. Once the transaction has been completed, a confirmation is communicated across the chains, followed by a waiting period for extra security. After waiting the period, the equivalent number of coins is released on the sidechain, allowing the user to access and spend them there. The reverse happens when moving back from a sidechain to the main chain. Now moving on to the next question is, can you name one major limitation of blockchain? So as everyone knows, cryptocurrencies has had a fantastic year in 2017. But now with more tokens, users, investors, exchanges, and startups involved than ever, scalability is emerging as a serious issue. With transaction data piling up, the current system is beginning to strain under its own weight. With every purchase, the blockchain adds one more block to its ladder of transactions, and every block increases with data as it carries the history of the block before it. As more users join the network and transaction histories of individual coins grow, the current system is in danger of buckling. So, as we see, scalability is basically the major issue in blockchains today. Now moving on to the next questions, are there any alternatives to blockchain? So, yeah, there are actually alternatives to blockchain. Hashgraph is a new consensus alternative to blockchain. it uses a gossip protocol that works in the following manner. Every node in Hashgraph can spread signed information called events on newly created transactions and transactions received from others to its randomly chosen neighbors. These neighbors will aggregate received events with information received from other nodes into a new event and then send it on to a other randomly chosen neighbor. This process continues until all the nodes are aware of information created or received at the beginning. Due to the rapid convergence property of gossip protocol, every piece of new information can reach each node in the network in a fast and very easy manner. Okay, now moving on to the next questions. Do you know the means to scale a blockchain technology? Well, the first method to actually scale a blockchain technology is a Lightning Network. Now, this was proposed to a solution to Bitcoin scalability. So what it does is implement off-chain transactions, which means basically not the entire list of transactions happen on the main chain. Only the first transaction may happen on the chain, then all the following transactions happen on a side chain, which takes lesser work and lesser space. And then the final transaction is again updated on the main chain, maintaining the integrity of the network. While this is a skewed approach, it kind of works in today's world. Next, we have SegWit, which stands for Segregated Witness. So in SegWit, the signature data will move on from the main chain to the extended block in the parallel chain. What this will do is that it will free up a lot of space in the block itself for more transaction. It was envisioned that the signature data would be arranged in the form of a Merkel tree in the side chain. The Merkel root of the transaction was placed in the block along with the coin-based transactions. However, on doing this, developers stumbled upon something unexpected. They discovered that on putting the Merkel root in the particular place, they somehow increased the overall block size without actually increasing the block size limit. After that, we have another practical approach, which is increasing the block size. So with increasing transactions, the possible solution is to actually increase the block size to just accommodate more transactions. But in my opinion, that's just a lazy approach. Lastly, we have sharding. Now, sharding is a scaling technique that was inspired by a traditional concept of databases sharding, whereby a database is partitioned into several pieces and placed on different servers. In the context of a public blockchain, the transaction load on the network would be divided into different shards comprising different nodes on the network. As a consequence, each node would process only a fraction of incoming transactions, and it would do so in parallel with other nodes on the network. Breaking the network into shards would result in more transactions being processed and verified simultaneously. As a result, it becomes possible to process more and more transactions as the network grows. This property is also referred to as horizontal scaling. Now, we could imagine that existing blockchain operates like a busy highway with one toll station operating only on one toll booth. The result would be a traffic jam as people wait in long lines to pass the toll station. Implementing a sharding-based blockchain is like adding 15 or 20 toll booths to the highway. It would dramatically improve the rate at which traffic can progress through the stations. Sharding would make a tremendous amount of difference and dramatically improve transaction speeds. So moving on to the last question of the session for today, we have, with blockchain came the Web 3.0. Can you name some of the decentralized blockchain-based applications that will bring about the next level of the internet? So the answer to that is, you could name some of the applications that have been actually implemented through blockchain. For example, browsers like Chrome have been implemented in a decentralized manner called a Brave browser. Then we have storage file systems like Storj and IPFS. We have operating systems like Essentia and EOS, and social networks like Steemit. So as you guys can see, there are a lot of blockchain-based applications that are actually replacing all the currently centralized services. So yes, indeed, we can actually call the internet run on blockchain the Web 3.0. So guys, that was the end of all the blockchain-based questions that you might face during your interviews. I wish you the best of luck for all the interviews that you might be appearing for. That's it from me. Goodbye.